Good day, my name is Jonathan Soon. Today I'll be showing you my IPsec over GRE Tunnel lab. So in this lab, basically I'm going to be showing you how to set up IPsec over GRE Tunnel. Um, Previously I made a GRE Tunnel video with all of the configs for both the CentOS machine and the Windows client, as well as the routers. Everything all the commands I used is in that video. I went over it very extensively, so I won't be doing that in this video. Before we start, let's just give you a quick definition of IPsec. So IPsec is a group of protocols for securing connections between devices. IPsec helps to keep data sent over public networks secure. Sorry. It is often used to set up VPNs, and it works by encrypting IP packets along with authenticating the source from which the packets originate. Security protocols such as IPsec are necessary because networking methods on the open internet are not encrypted by default, so it's definitely not secure. So basically, the purpose of this experiment is to determine if I can use an IPsec tunnel to receive DHCP at the other end of the tunnel and/or have a client machine join a domain via the tunnel, and to see if the tunnel will allow broadcast and multicast transmission. So I'll be using OSPF, which is multicast, to set up the network initially. And then in a second experiment, I will use RIPV2, which is broadcast. And in this experiment, we'll determine if an OSPF neighbor relationship fails to be established within the tunnel. This will be direct evidence that IPsec only promotes unicast traffic. So let's get on with the commands. Also, before I start, instead of crypto maps, I'll be using tunnel protection profile. This is more of a modern method. So this is for GRE over IPsec. It's cleaner and more scalable, especially in labs and real world scenarios. So that's what I'll be using. Um, okay, so let me just show you the commands I'm using. I'll just quickly browse through my router commands for GRE Tunnel. Um, I won't be explaining anything really because I already explained everything in the GRE video. No point really repeating everything. So here are the commands. Just scrolling through. That's the tunnel I'm be using. Interface tunnel 10. I ran OSPF on all of the routers, and well, obviously the tunnels will be on routers 1 and routers 4. And I put IPsec profile on routers 1 and 4. So now let's start off with the IPsec commands. So this will be phase 1. Crypto ISA KMP policy 10. So this defines this word policy with a priority 10. So lower numbers have a higher priority. This command, it just basically I'm using a AES 256 for strong encryption for phase one key exchange. I'll be using hash and SHA. Well, it uses the SHA hashing algorithm for integrity checking. Authentication pre-share. So this specifies that a pre-shared key will be used to authenticate peers. Group 5, this uses the Diffie-Hellman Group 5. So this signifies that so this defines how the shared keys is securely negotiated. Lifetime, this it sets the key lifetime to 24 hours. 86,400, that's 24 hours. The next step, this one. This command basically it authenticates the IPsec peer. So ISA-KMP key. This defines the shared secret password for authenticating with the peers at the specific IP address. So this will have to be the same on both routers. So they have to match on both sides. And then we head into phase two. So in phase two, basically these commands they define how GRE packets will be encrypted. So this first line VPN set. So this will be the name of the transform set. ESP AES. This enables ESP encryption using AES. And it's not just a header encryption. And the rest of the code, this adds ESP integrity using the HMAC SHA. And then mode transport. This basically it tells IPsec to encrypt only the payload and not the new IP header. So it's really ideal for GRE tunnels. The next part of the code is the name of the profile that we're going to be using. So I'm using IPsec GRE. That's the name of my profile. Set transform. This just applies the previous determined transform set to this profile, to my new profile here. So profiles are used with the tunnel protection for GRE slash IPsec integration. And well, this interface tunnel 10 with tunnel protection, this activates IPsec encryption for that tunnel. So tunnel 10 and then my profile, this will secure all GRE traffic over tunnel 10 using my profile. And that's it for the commands. I did the same thing for R4, but obviously different IPs because it'll be on the other side. It'll be on this side, R4, and R1 is all the way on the left. So yeah. So let's head into the routers now. Okay, so that it shows you the source, the router used. Let's see this next command. It was this one. Right, so this command will show you exactly how the packets are being encrypted. Where is it again? I think I just passed it. Okay, right here. So it says 900 encrypted and then decrypted. So in a previous, well, if you saw my GRE video, you would see that when I did the tracert command, it would come up fairly quickly, but you'll see later on when I test it again with IPsec enabled on this, it will take a bit longer that's because all the packets have to be encrypted and decrypted on both sides, and then it's jumping around from different routers. So that's why it will take quite a while to come up. Okay, so let's show you this command here. What does it actually do? So how do you even read these things? 1 second. Okay, so some of the key things to look out for when I'm using this command. So you check the state and then you see QM_idle, and then state active. So this means that you're in quick mode, which means that phase one completed and authenticated successfully. So that's a good thing. Let's just scroll down. As I mentioned earlier, I keep forgetting. Right here. Um, this will when I ping, let's say my let me see this. If I ping my Windows client from this machine just to generate some traffic, you'll see okay, some pings there, and now let's go back on this Windows and ping over here as well. You'll see that the number will increase. So I'll let this keep pinging, and you'll see that the numbers will increase. So right now, see it's like 235 and then decrypted 445. It will be more um, once I once I finish ping. So the next command I use is do show interfaces tunnel and do show interfaces tunnel 10. So this will show you what your tunnel 10 has. The main part you want to see is tunnel protection via IPsec profile, IPsec GRE. So that's, remember when I set this up, this one right here, that's the profile that I set up. So this confirms that the tunnel is encrypted using the profile that I just set up. So let's check back this command and see if, yeah, so you can already see that number has increased by a lot. I guess I'm blind. Okay, right there. Yeah, so remember it was like 235. Now it's up to 1,000. So you can see there's activity on the on the tunnel itself, and there's it increased. So let's just stop this ping. Okay. So I mean already did a ping test. Already did a ping test, but if we do it again, you'll see it adds more packets, right? So last thing, let me just show you what I have on this one as well. This is R4, and Okay, you'll see the same thing. QM idle, and then it's active, and then check this. Right, and yeah, you can see even more. Yeah, so this on router 4, this was getting even more traffic because um I left the ping on for so long, so it pinged a lot. That's why you're getting so many encryptions, and it's yeah, it encrypted a lot and decrypted a lot as well. So let's do a trace route on this just to see how long it takes. And I'll do it on this Windows machine as well, just to see how long it takes. Okay, so this one is done. Usually, okay, that was actually pretty fast. Not bad. Pretty quick. And then this one, like I said, I'll take a little while. Okay, good. So from my tests, it is actually slower, and that's because of IPsec, like I mentioned earlier. You know, it just takes so much time to encrypt and then decrypt, jump from router to router. So now that we have that done, okay, so one of the last things I'm going to show you on this, on router 1 is my OSPF neighbors. So you can see this network and the 5 network. This will be the tunnel. And then on this side, the tunnel again, and a 9. So the 5 network would be over here, and the 9 network would be here. So now let's just continue on with the experiment. So I was supposed to show you that I'm receiving DHCP from my CentOS machine. Well, I showed all of this already in my GRE video, but just to show you it's still working. I'm receiving DHCP. The .100 was the first in DHCP, first IP address that I set. So let's just confirm it here. Obtain, yeah, obtain automatically. And that's my DNS server right there. So you can see DHCP enabled, yes, DHCP server. This is my CentOS machine, and then DNS as well. So the last thing we're going to check is whether or not whether or not I was able to join this machine to a domain. So you can already see that is the case. I'm just going advanced, go on computer name. You'll see my domain is John already, but the user that I created was user SMB user. So let me just show you really quickly and signed in. And then we'll head into the RIP version 2 side of the experiment, and we'll see whether or not it works. Okay, as you can see, yeah, it literally just logged in. So you can see here, SMB user, I logged in. Let's go check the name. Okay, stick in. Okay, so it finally decided to move. Right, so as you can see, I'm logged into this device and I'm I joined the domain. So that concludes this part of the experiment. Next, I'll be showing you the RIP version 2 part of it. Okay, so I'm back. I just finished configuring the RIP side of the lab. So we'll be using RIP instead of OSPF. So basically, I just removed OSPF from all of the routers and added RIP version 2. Here is my code, my command, sorry, for RIP. I just put no, let me just, yeah, no router OSPF1, and then we added RIP version 2, not a summary, and then added all the networks, and I did that on each one of the routers. So now I'm just going to show you, oh yeah, before I do that, I'm still getting DHCP. As you can see, even in RIP, still getting it, and my trace route is still working. Uh, this takes a few seconds, but still works. Yeah, perfect and perfect. Also, sorry for the background noise. Right, so that works. Now let's go on to the routers and show you what I did. So first thing I did was do show router rip route row. Yeah. And you can see that it found my Windows client, right? Through the GRE tunnel because it went through the 20.20.20.2. That's inside the GRE tunnel. It also found the two other routers, router 2 and router 3. Now we can also use this command and you'll see rip updates in real time. So I'll just leave it on for a couple seconds so it will start updating. It's receiving updates right now. And then I can write, once you finish checking the updates, just do unbug all, right? So let's take a look at what the updates showed us. So where's the command? Right here. So RIP version 2 update from the tunnel. So we scroll down, you see it's finding my client machine. Scroll down a little bit. Okay, this is what I want to show. It says send in version 2 update to this via the tunnel, which this is the tunnel R1 side. This would be on this side. So you can see that it actually got updates from the tunnel. And then if we do well, that's when I added the stuff. Let's see it on router 4. Let's check out what's going on this router. Right. We found a CentOS machine through the tunnel, which is good. Let's do debug really quick. Check out the updates. Have this command ready. Okay, that's enough. So you can see we're already getting updates from the tunnel. Anytime you see 20.20.20 or 1 or 2, that means it's coming from the tunnel. So we're receiving updates from the tunnel. So in conclusion, oh yeah, also before I even say that, I'm still logged in into my into my domain. I won't log in again because I think I've already proven that. Yeah, that's that. And I'm already getting DHCP. I think that should be enough proof that it's actually still working. The GRE is still working as well on both sides. So in conclusion, this lab proved, well, this experiment confirmed that RIP version 2 routing updates, which rely on broadcasts or multicast, do not work over IPsec, which supports only unicast, but it functions correctly when encapsulated inside a GRE tunnel. And by applying IPsec tunnel protection to GRE, the network supports encrypted communication, routing protocol functionality, and also secure broadcast transport, right? So GRE over IPsec is a viable solution for secure dynamic routing across untrusted networks. And the last thing is, even though IPsec doesn't support multicast, GRE does, and IPsec encrypts the GRE packets, not the multicast directly, so it does work. So the last thing I'll be showing is once again this command, show crypto IPsec SA, and it's the same thing as before. You know, you can just see all the packets that's being encrypted and decrypted. And yeah, and it's still being protected by the IPsec GRE. So that will be all for this video. Thanks for watching. Hope it was helpful.